Example 2. Sketch shows the curve with parametric equations x equals 1 minus a half t, y equals 2 to the t minus 1. Curve crosses the y-axis at A, which has coordinate 0, 3, and the x-axis at B, which is 1, 0. The region R is bounded by the curve x equals minus 1, and the x-axis, find the area R. So, area under a curve, integral of y dx, it's parametric, dx by dt dot dt. So we are going to substitute in for y, and we're going to substitute in for dx by dt. X equals 1 minus a half t, so dx by dt, 1 differentiates to nothing, minus a half t will be minus a half. And we also need the limits, so I'm going to make sure I get the limits correct first time. So integral, so we are integrating from x is minus 1 through to x is 1. So from minus 1 to 1 for x. So x is minus 1, 1 minus a half t. So a half t will equal 2, t will equal 4. Sorry. And then subbing in 1, 1 equals 1 minus a half t. Take away is 0, minus a half t, t equals 0. So our limits for x were from x is minus 1 to 1. So when x is minus 1, that value is 4. And then when x was 1, that value is 0. 4 to 0. Now that looks a little different, but that is the order they need to go in. Now we can do something with that later on, and I'll talk about that in more detail when we get to it. So change my limits to be in terms of t, and now subbing in for y, and y equals 2 to the t minus 1. Subbing in for dx by dt, which is minus a half, dot dt. So we are integrating 2 to the power of t. There's our variable. That minus a half here is just a constant. Now, I'm going to talk about the 4 to 0 here now. And I'm not going to dwell on it too much, but we are going to, once we've integrated this, sub in 0, and then take away, and then sub in 4. And whatever that gets us there is going to be the answer. Now, we are timesing here by minus a half. So, timesing by minus a half, we're presuming, because it's above the curve here now, that this is a positive area. So, when we sub into the integral here now, this must be negative times by negative to get us a positive. So there's a lot of negatives going on there. So if when we sub in the 0, take away and sub in the 4, this is negative, we can change the limits around to be 4 and 0, which is something we're more familiar with, sub in 4, sub in 0 and take them away. And change this, rather than being a timesing by negative a half, timesing by positive a half. So then rather than being a negative times a negative to get us a positive, we're doing a positive times a positive. And that just seems a little easier there. Now I'm going to take the half out as well, and then I'm going to integrate. So half comes out, square brackets, and now we're going to integrate. So 2 to the t. So I'm thinking to myself, how would I differentiate 2 to the t? What is d dt of 2 to the t? Well, that would be 2 to the t log 2. 2 to the t log 2 is how we differentiate 2 to the t. So the integral will be rather than timesing by log 2, we're going to divide by log 2. So that's 2 to the t over log 2 minus 1 will go to a t. The half we dealt with by taking it to the front. Limits are 4 and 0. So we've got a half bracket 2 to the 4 over log 2 minus 4 minus 2 to the 0 over log 2. Take away 0, so we just have that there. So we have 16 over log 2. Now this here is 1 over log 2. So that's take away 1 over log 2. And then we have minus 4. So last couple of steps here. A half bracket 15 over log 2. They've got a common denominator, 16 take away 1, minus 4. And there's our answer.